Dear students, now we are going to continue with the local anti-infective agents. So already we have seen cresols. So these are otherwise called as methyl phenols or hydroxytoluenes. So three cresols are there. One is called as orthocresol, then metacresol, paracresol. So now we are going to see chlorinated cresols or chlorocresols. So cresol with one chlorine. So this is orthocresol with one chlorine in the para position, that is called as chlorocresol. So this is a otherwise called as a chlorinated phenol or a methylated phenol, and used as an antiseptic and preservative. So next one is thymol. So look at the structure of thymol. We have metacresol. So that metacresol is connected with isopropyl. So that is called as thymol. What is thymol? Metacresol with isopropyl group. So what it is? It is an isopropyl metacresol used as a preservative, anesthetic, and also as an antiseptic in mouthwashes. It is having fungicidal property. It is used in dusting powder for the treatment of ringworm infections. So next one is called as resorcinol. Benzene ring with the two hydroxy groups, both are meta to each other, means that is called as resorcinol. Meta dihydroxybenzene. So that's why it is otherwise called as meta dihydroxybenzene or 1,3 isomer of benzene diol. So this is number 1, 2, 3. So 1,3 isomer of benzene diol. It is used as an antiseptic and disinfectant. So next one is the hexyl resorcinol. So resorcinol with the hexyl group. So this is the structure. So this is resorcinol with the hexyl group. That's why this is hexyl resorcinol. We'll see the synthesis. First we are taking resorcinol, that on reaction with the hexanoic acid, 6-carbon acid is called as hexanoic acid. By the addition, so here H and this OH removed as water. That's why the left group is added there, and we are getting this compound as an intermediate. Now we are going for Clemmensen reduction by using amalgamated zinc. So by means of Clemmensen reduction, the carbonyl group, that ketone, that is converted to active methylene, and that is converted to a hexyl group. That's why this is called as a hexyl resorcinol. It is used as an antiseptic. It is having bactericidal and fungicidal properties, having local anesthetic action. So next one is eugenol. So look at the structure of eugenol. We have the parent as phenol. So we have a phenol, in second position methoxy, fourth position we have an allyl group. So that's why it is called as 4-allyl 2-methoxyphenol. It is having 85 to 90% of clove oil. It is also present small quantities in cinnamon oil and also in other volatile oils, used as a local anesthetic, antiseptic. It is directly applied into the tooth by the help of a piece of cotton for relieving toothache. It is used in mouth washes because it is having antiseptic property and also having pleasant taste. So now we are going to see the next one, that is oxidizing agents. These can act as germicides because they react in the tissues and they are generating oxygen and oxy radicals. That is, that activity is depending on the ability to form or ability to generate oxygen in the host. So they generate oxygen and oxy radicals. Examples are hydrogen peroxides, metal oxides, and sodium perborate. So first type is hydrous benzoyl peroxide. This is the first example under this, hydrous benzoyl peroxide. So look at the structure. We have two benzoyl groups. In center we have two oxygen, that is called as hydrous benzoyl peroxide. It is otherwise called as benzoyl oxybenzoate. 5 to 10% concentration is used as a keratolytic and keratogenic, that is used in the treatment of acne. And next one is carbamide peroxide. So this is the structure, NH2CO NH2 H2O2. This is carbamide peroxide. Why? Because carbamic acid is NH2COOH, that is called as carbamic acid. If this acid is replaced by means of amide, that is called as carbamide. NH2COOH is carbamic acid, NH2CO NH2 is carbamide with peroxide H2O2. So otherwise called as urea peroxide or urea hydrogen peroxide or percarbamide. It is having 35% of hydrogen peroxide, used as an antiseptic or disinfectant, and also used in the treatment of oral ulceration and also in dental care. So next one is iodine compound. Under that example is povidone iodine. So this is the structure of povidone iodine. We have a pyrrolidine that is connected with the ketone. Pyrrolidine on pyrrolidinone, and that nitrogen is connected with the vinyl. It is a polymer also. That is in the first position. It is connected with vinyl, and this is a 2-pyrrolidine or pyrrolidinone and a polymer compound. So what is pyrrolidine? Pyrrole without bond, that is called pyrrolidine. CH double bond CH2, that is called as vinyl. So here first position is connected with the vinyl and second position we have a ketone. So pyrrolidinone, 2-pyrrolidinone, and it is a polymer. This is used to prevent or treat infections in minor wounds, cuts, and also on the skin before surgery. It works by slowly releasing iodine. It slowly releases the iodine, and that iodine kills the microorganisms. So now we are going to see chloride compounds. So first one is benzalkonium chloride. This is otherwise called as BAC. So look at the structure of benzalkonium chloride. What is it? This is having benzyl. That benzyl is connected with dimethylamine, and that nitrogen is connected with one more R. R is alkyl. This is a quaternary nitrogen, and that is connected with the chloride. That's why it is called as benzalkonium chloride. Here R is alkyl. So this is a general structure consisting of three parts. One is a positively charged hydrophilic head. So look at that, we are dividing the structure into two. So R is one part and left is another part. So the left part, no, without R, that is called as a hydrophilic head, and that is a positively charged one. And R, we said no, that is an alkyl chain. How that is? That is a long non-polar lipophilic alkyl chain. So this part is hydrophilic and R is lipophilic. So this is having positively charged, whereas this is a long non-polar and lipophilic one. How the nitrogen is? That is a quaternary ammonium group. So it is a mixture of the compounds with varying alkyl chain length. Here how the R is, that may be C8 to 18. So the number of the carbons in the alkyl is starting from 8 and up to 18. It is used as an effective germicide and preservative that is mostly used in cosmetic industry and medicine. So now we'll see the synthesis of this benzalkonium chloride. For this, first we are taking tridecyl alcohol. So how many carbons are there? 13 carbon alcohol is called as a tridecyl alcohol that undergoes chlorination by means of PCl5. So here the OH is replaced by means of Cl and we are getting tridecyl chloride, and this one is reacted with benzyl dimethyl aniline. So this is called as benzyl. So benzyl dimethyl aniline, both would be fused, and finally we are getting benzalkonium chloride. So with the nitrogen is already having the two methyls. This tridecyl part and chlorine would be added here, and we are getting benzalkonium chloride. So in the benzalkonium chloride, the alkyl carbon of the alkyl vary from 8 to 18. So now we are going to see the next drug that is called as benzithronium chloride. So look at the structure of benzithronium chloride. So first it is having benzyl. So this part is called as benzyl. That benzyl is connected with dimethylamine, that is connected with two ethoxys. So what it is? First we have a benzyl that is connected with dimethylamine, that is connected with two ethoxys. That ethoxys are connected with phenyl. That phenyl is connected with isopropyl, then with methyl, then with tertiary butyl. So what is benzithronium chloride? Where this group is added to the para position. So benzyl connected with dimethylamine, two ethoxys were added, and that is connected to phenyl. This phenyl, with the phenyl, fourth position we have isopropyl, methyl and tertiary butyl, and connected with one chlorine also. That's why benzithronium chloride. So this one is a synthetic quaternary ammonium salt with the chloride as a counter ion used as a surfactant, antiseptic, and it is having anti-infective properties, used as a topical antimicrobial agent in first aid antiseptics. So next drug is called as methyl benzithronium chloride. Everything is same as that of benzithronium chloride, extra methyl is there. So second position is connected to methyl, that is called as methyl benzithronium chloride. So it is used in the treatment of a diaper rash in infants, and that would be caused by Candida albicans, and that is producing ammonia, used as a general antiseptic. So next one is acetyl pyridinium chloride. So look at the structure of acetyl pyridinium chloride. So this is called as acetyl. What is meant by acetyl? That is hexadecyl. So 16 carbons are there. So 14, 15, 16. So 16 carbon alkyl is called as hexadecyl, otherwise called as acetyl. Pyridine that is connected with that, and like a quaternary ammonium, so that's why that is called as pyridinium. So acetyl pyridinium chloride, how the structure is pyridine with the pyridine nitrogen. Already the nitrogen is satisfied. Here the extra alkyl will be added, that's why that is getting positive charge. So which alkyl would be added? Acetyl. What is acetyl? Otherwise called as hexadecyl, that is 16 carbon alkyl, that is called as acetyl. So acetyl pyridinium chloride. So what it is? This one is hydrophobic in nature. It is used as a local anti-infective with the surface active and antiseptic properties. It is used in lozenges and mouthwashes, and the nature of the alkyl group is hydrophobic. So next one is chlorhexidine. So look at the structure of chlorhexidine. We have biguanides, that is two guanidines were fused and forming a biguanide. So this is one biguanide, this is one biguanide, and that biguanides are connected by means of hexane, that is 6 carbon, 1, 2, 3, 4, 5, 6. 6 carbon alkane is called as hexane. So biguanides, two biguanides are fused with the hexane, and another end of biguanides are having parachlorophenyl, that is called as chlorhexidine. So how do we divide the word chlor? Chlor is indicating that parachlorophenyl, hex is indicating that hexane, den is indicating that biguanide, that is guanidine. So what is chlorhexidine? We have the hexane in the center, and that is connected with the two biguanides on both the ends, and that biguanides are connected with parachlorophenyls, that is called as chlorhexidine. So it is bactericidal agent. It is used topically as a preoperative skin disinfection, wound irrigation, mouth washes, and general sanitization. So next one is called as gentian violet. This is otherwise called as crystal violet or basic violet 3. So look at the structure. We have 3 benzene rings, actually 2 benzene rings. This is also like a benzene ring, but one bond was not there. That's why this is called as cyclohexadiene. So 3 rings are connected to the center carbon. So these 2 are benzene rings, and this one is called as cyclohexadiene, and all the 3 are having dimethylamines. So because of the presence of extra bond, this is getting positive charge and connected with the chlorine. So we have a triaryl methane. So it is having triaryl methane di. So what it is? It is a triaryl methane di. And actually it is a derivative of para-rosanilin. So what is para-rosanilin? So 3 rings are there, 2 benzene rings. This is not a benzene ring. This is called a cyclohexadiene. All the 3 are connected to the center carbon. And how these rings? These are connected to NH2. NH2. Only this is getting positive charge. This is called as para-rosanilin. Compare para-rosanilin with the gentian violet. Here the 2 hydrogens are replaced by means of 2 methyls. That's why where the methyls are added with the nitrogen. So how many methyls totally? 2, 4, 6. So that's why it is called as N-hexamethylated derivative of para-rosanilin. So it is having 3 phenyl rings attached to the center carbon. So 3 rings that is attached to the center carbon atom, and a lipophilic cation. So this is a lipophilic cation. So this is used primarily as a biological stain, mainly as a primary stain in gram staining to differentiate bacteria by the cell wall thickness. It also acts as a topical antimicrobial agent. It is used in various laboratory and medical applications like staining cells or checking the cell viability, and for treating the fungal infections like a thrush and ringworm. Also used as an antiseptic. So next one is called as methylene blue. So look at the structure of methylene blue. So it is having the nucleus as phenothiazine. So these two ends are connected with the dimethylamine, having chlorine also. So what is methylene blue? Phenothiazine. Both the ends are connected with the dimethylamine. This one is having antiseptic properties. It is used in the treatment of methemoglobinemia. So next one is called as nitromerzole. So look at the structure of nitromerzole. So totally, actually we have 8 atoms here. So this is having 6. Well, adding these two, totally 8 we are getting. In that 8, it is having 3 bonds. So triene. So a total 8 with 3 bonds. So octatriene. With the octatriene, it is having 2 rings. No, this is 1 ring, this is 1 ring. So bicyclooctatriene. So along with it, it is having oxygen and mercury. That's why it is called as oxa mercura bicyclooctatriene. So what it is? It is a oxa mercura bicyclooctatriene having 2 other substituents. One is methyl, another one is nitro. So what is the parent present here? Oxa mercura bicyclo. This is 1 ring, this is 1 ring. Bicyclooctatriene. This is otherwise called as metformin. It is used in the treatment of ocular infection. So next one is called as thiomerzole. So look at the structure of thiomerzole. So what would be the structure? We have the benzene ring that is connected with the sodium salt of acid. This end is SHgC2H5. So look at this. We are dividing the name into 3, that is thiomerzole. Thio is indicating the sulfur, and mer is indicating that mercury, sal is indicating that salicylic acid. So it is a sodium ethyl mercury thiosalicylate. So what is that? Here we have acid. No, acid is replaced by means of sodium salt of acid. That's why sodium. And here OH we have, no, that O is replaced by means of sulfur. That's why thiosalicylate. And H is replaced by means of ethyl mercury. That's why ethyl mercury thiosalicylate. So sodium ethyl mercury thiosalicylate. So what is the difference? Here H is replaced by means of Na and O is replaced by means of S. H is replaced by means of HgC2H5. So that's why it is called as a sodium ethyl mercury thiosalicylate, otherwise called as a thiomerzolate sodium. It is used as a disinfectant and preservative. So that's all about the local anti-infective agents. Thank you.